So I guess I really wanted to present some recent work that myself and my lab have conducted, and actually we've submitted a preprint into a kind of a leading cardiac journal. And as I guess Richard was kind of alluded to, we are really on the front line in trying to answer some of the clinical questions that we have right now in the fight against COVID-19. So I really want to present, what the kind of clinical questions that we actually answered, or like at least try to seek some answers to, the kind of data sets that we've had or performed some rapid analysis on. And more importantly, actually, probably the audience is probably more suitable for this, but the kind of technologies that we've developed in the past and really applied to this problem. And I think as hopefully this talk will kind of allude to the fact that a lot of this technology is actually open source. It's produced within our group and a couple of other groups. We actually want to take this further to multiple hospital trusts, not just to the trust that we've kind of performed this rapid analysis upon. And it's really, we should really see this as an opportunity to really, harness the tools that we have, harness the data we have, and really try and answer some of these really key clinical questions. So hopefully, after this session, the slides will be made available. There's a couple of links in the slides, both to various GitHub repositories, as well as the actual preprint of the paper, if you want to take a closer look as well. Okay, so out on the talk, we really want to get into why we even perform this analysis. I guess we really want to answer the questions that affect patients right now. I really want to get towards this state of evidence-based medicine as opposed to the art of medicine, or a clinician having to apply their clinical judgment, which may or may not be wrong, but really they're kind of up to that kind of chance mechanism of have they read the correct research recently, or have they come to conclusions recently according to the data that they've seen within their department. So I think we are getting there, but hopefully research projects like this and many others that really try and harness the data with using secondary usage of said data will really get us towards this evidence-based medicine approach. So I really want to talk about the electronic health records that we have available at King's College Hospital Foundation Trust. It's a multi-site center that we perform this analysis upon. If you ever hear and do more further background reading around EHRs, then it may also be referred to as electronic medical records, electronic patient record systems, so EPRs, also known as clinical notes or medical notes, and we'll kind of get into details of what this really means.
Hey Tom, are you supposed to be sharing that screen or not?
Which, are you not seeing slides?
No. We're seeing some work that you're doing.
Okay, that's interesting.
I didn't know if that was part of the presentation.
Okay.
All right, we got your Spotify, we got your homework, we got some slides. Everybody happy?
Got some slides? Got some slides. Okay, great. Okay, so we can kind of do a repeat of the introduction of the actual talk, but it's really a discussion of this preprint that we've recently submitted to a leading cardiac journal. So I guess in outline, we're really going to talk about we're really going to focus on technologies used and really focus on the natural language processing of kind of applied using these technologies, and how this has really informed our understanding of COVID-19. It's still really early days for this research, predominantly on for reasons of there is still a fairly small data set when it comes to like our patient number that have reached the outcome measure that we were interested in. But yeah, let's get into it. So what are the COVID-19 clinical questions that we tried to answer in this work? So the angiotensin converting enzyme 2 receptor is a known entry point for COVID-19. So this is actually known due to our understanding of the protein structures of the virus and how it enters into the cell. So kind of given this, there was an understanding within the medical community that hypertensive drugs, common hypertensive and diabetes drugs, ACI and ARB, so these are angiotensin converting enzyme inhibitors and angiotensin receptor blockers, may actually impact patients that are taking said drugs and have worse outcomes for those patients. So why would that really happen? I guess the general theory behind it was the upregulation of the ACE2 receptors after taking these drugs for a certain amount of time would mean that it would leave you open to, this virus infecting, just spreading throughout your body, infecting many cells very easily. But I think there is actually a certain amount of published work, both in Lancet and various other journals that have gone under rapid review to say that there is an increased risk, with a very small sample size. So, we can kind of leave that to another day. But then there's more work that's actually gone to say the reduced renin-angiotensin system, so the RAS activation, actually means that this could be protective when there's severe lung injury. So often you have COVID-19 patients that contract pneumonia, be it viral or bacterial, and actually, end up dying from that, having worse outcomes than those that don't. So yeah, there's a general consensus. There is not a clear consensus of whether there's an increased risk if you're taking these hypertensive or these common hypertensive or diabetes drugs, or whether there's actually a protective factor in there as well. So there's some current research on the kind of both factors in the footnotes of this slide. So what did we actually try and seek to do? We really wanted to understand, given our EHR data, is it possible to kind of answer this question, from our cohort of patients that we have currently in KCH, King's College Hospital. It's a multi-site centre in the southeast of London, whether there are patients that have worse outcomes if they're on said drugs or not. So yeah, it's a fairly kind of simple hypothesis that we really wanted to test. And this is the data that we actually had available to us. We'll get on to how this data was made available to us in a second through various technologies that we've built. But what does the really data look like? So it looks like textual summaries from clinician observations. We have admission and discharge summaries. We have imaging reports, whatever kind of modality you're after is all kind of within the EHR. So it's within that record, as well as the high resolution images themselves. So there's X-ray, MRI, fMRI, CT scans. So that's really on the unstructured side. With the structured side of things, you're really looking at patient demographics. So you have, age, gender, what actual medications they're on. So that will also actually be in the unstructured side of things in the free text. But the medications, if they're within a pharmacy, they've been prescribed certain meds, then that should be over a certain course, that will be available in the structured fields as well. They'll have the outcomes of whether they've either been admitted to an intensive care unit or intensive triage unit, whether they've died or whether they've been discharged. We also have time series of vital signs of blood pressure, heart rate, oxygen saturation, reported pain levels. So various other fields will all fit in there. So all of that data is within normally within a standard electronic health record, electronic medical record. So the kind of technologies that we looked into, I guess, and we used for this rapid analysis. All of this has actually been built within our lab over many years. So definitely can't take full credit for this. So please do check out the links when you do have access to the slides. So briefly, I'll just cover these three technologies, and then we'll get into the latter two about how they work. That's really the more interesting natural language processing side of things. So CogStack is it's a near real-time ingestion and harmonization technology that really indexes in EHR and makes it free text searchable. So I don't know if others on the call have heard about a technology called Elasticsearch. It's primarily based on a kind of a Leucine index, which is uses similar technology the way Google has essentially indexed the internet and made it free text searchable in terms of the text. There's other bits of technology within CogStack, which means it can take a PDF, for example, that's been produced in a certain department, runs OCR, converts it into its base rawest form or its raw text form, concatenates that all into a single document for that patient, and then structures it all together so you can free text search both the free text as well as the structured fields. So that really provides the data to us, I guess. So MedCat is the medical concept annotation tool. It's a named entity recognition and linking tool, which really takes the text, reads the text, and tries to identify any clinical ontological data within it, and then links it correctly to a given ontology. So we'll get into that in a second. The MedCat trainer is an annotation and active learning interface for training MedCat. So MedCat is both it's an unsupervised as well as supervised learning tool that really pulls out the kind of interesting parts of an EHR or the unstructured parts of an EHR for you to then perform further analysis. So what do we really want to do, right? So we have we have patients that are on medications. That's in the structured field. We have their demographics, so we have their age and gender. So, you know, these are things we can account for in classic statistical models. One thing we don't have is the comorbidities. So we don't have the fact that if they're hypertensive, or if they're receiving those ARB or ACE-I drugs for some other reasons, we don't have whether they're actually diabetics and what type it is. We don't really have any other comorbidities that we could be interested in. So we really need to use MedCat as a tool to really learn the concepts of, you know, those ontological concepts of diabetes or hypertension, and then really pull out those concepts from the unstructured portion of the EHR. And then that gives us a representation of whether these patients, you know, have hypertension or not, whether they have hypertension in, you know, whether it's a negated form of that, or whether it's temporality form. They used to have an uncontrolled type 2 diabetes condition, and now it's controlled. So all these kind of interesting angles are those comorbidities are really interesting to us. There's no way of us pulling that data out unless we actually read the note or we use something like MedCat. So that's really the kind of concept embedding. It's very similar to Word2Vec in the way it learns a fixed distributed semantic vector, which is almost like it's a 300 dimensional array. That's each floating point number within an array would have some form of the semantics captured of that given concept. So the example here is hypertension is also known as, in the records, is known as HDN, hypertensive, high blood pressure, the caret sign, then blood pressure. So all these words mean hypertension essentially within the text. So we really want to map those free text terms to the concept hypertension. There's further models that we use, probably by LSTMs, for meta-annotations. So once you've annotated hypertension, you want to figure out that hypertension could also mean, or could be referring to, a familial version of hypertension, so that a family history of hypertension. It may not be experienced by the patient. It could be hypothetical. So I've got an example down here of a patient was prone to a gastrointestinal bleed. So that's kind of MedCat. MedCat Trainer is the annotation interface. You can see it on the previous slide, and you see on this slide where it says meta annotations. This is really for collecting data around temporality, you know, negations, hypotheticals that we kind of previously spoke about. So this is really just kind of a pipeline in a way we can identify interesting comorbidities, for example, within EHR text. So its conclusions of this work. So we pulled out all of those interesting concepts, whether people had hypertension, diabetes, and any other comorbidities that we were interested in, created a statistical model, and accounted for age and gender, and really found that there really wasn't an issue with worsening outcomes, where outcome was measured from a 7-day being admitted into A&E department, and a 7-day outcome measure of either death or admitted to ICU. We really found there was no relationship between worsening outcomes and taking these drugs, which is it's a good outcome to, although it sounds like a negative outcome, it's a good outcome to get to, because it means current patients that are, you know, taking these very important drugs to manage their hypertension, diabetes, they shouldn't instantly stop taking it, which is what the previous research, you know, was. There was a lot of hysteria around, should I, you know, stop taking these drugs because it could worsen my outcomes if I contract COVID-19. In terms of further work, we're actually updating the models as we go. We have a pipeline of, kind of ready to go for both UCLH and GSTT and UCBH, so kind of all around the country that we're really going for. In terms of acknowledgements, yes, some collaboratives, some funders for my work. Thank you. Any questions, please? I think, or are we not doing questions yet?
Thanks so much. You've left 1 minute on the clock for questions. Congratulations.
Okay.
So put something in the chat or unmute yourself very quickly. It'll have to be pretty fast. Who's got a question for Tom? Okay. Tom, thank you so much.
Can I just ask a question? Richard, this is Jessel here. A quick question. Since we are using the EHR and it also looks at gender and age to predict things, there are certain problems which come based on the region from where you belong.
Yeah.
It's not a bias, but it actually is. So how does it deal with, or is it going to be done in the future?
Yeah, so this is really early stage work, as I was really trying to allude to in the very, very quick kind of findings conclusion slide. We really want to expand this work over to various regions around the country, and yeah, I guess the actual patient data set is, because it's only EHR, it's not the asymptomatic patients or patients that don't get admitted to hospital. So they're the less, they're the more serious form of COVID-19 patient. There's a slight bias there. But yeah, definitely we need to do more work there in kind of all classic kind of biology research.
Thanks.
Nice.
Thanks so much, Tom.
Thanks, Jason. How quickly can the hospitals use this information, Tom?
So it's a very good question, because I think if this is essentially a negative result, which is essentially saying we shouldn't really jump the gun at all and then ask all our patients that are currently on these drugs to stop taking them. I think the action we should do now is not panic, essentially, and not panic our patients by saying we should stop prescribing this medication and instruct them to instantaneously stop taking it. Because there's a very serious harm there if they've been taking these drugs, taking these meds over many years, and it's and they're worried about obviously contracting COVID-19 if they're in that high risk group. So they're using it now by actually just not really doing anything, which is also good as something doing the wrong thing as well.